Anyway, I believe Subsonic wanted to see a supernova. And a supernova is really easy to make in this game. Well, a Type 1A supernova, at least. Like, it's actually incredibly simple. All you do, random main sequence star. First of all, we don't need to shoot it this fast. 600 kilometers per second will do. So, random main sequence star, fire it right here, and get the heck out of the way. Well, when it shows up, anyway. Alright. Cyburn. That's a cool name for a star. Well, thankfully, time is still going really slow. Now we're going to speed it up. We're going to speed it up. I forgot, we're dealing on a much bigger scale now, because we're doing 2 stars. Alright, there we go. And now, we're going to zoom way out. For our own safety. And now watch as everything is consumed. No. Everything. Yep. So to give you an idea, let's take a look at Quawar here. The power of a supernova. So Quawar is way out here. The gas has not quite reached us yet out here in Quawar. Our temperature is 482 degrees. Like across the entire planet. Our temperature is 482 degrees. And yet the gas still hasn't hit us. Look, we're already bleeding out a trail of gas here. So let's slow down time real quick and just focus on Quawar for a little bit. Seizure warning in the upper right. But yes, now it glows. It just spews out more and more material. Yeah, this is the real solution. And now the surface becomes more and more molten. Well, let's stop real quick. Okay, yeah. If we stop time again, then it returns to a normal map. But like, Quawar's heating up so fast that the only way that the game knows how to register it is just by constantly turning the whole temperature map white. Also, you notice that sun is like omnipresent. No matter where I move the screen or the planet, the word sun is always there. I don't know why, but that's what happens. So yeah, molten. The whole surface is just completely engulfed in flame. Step by step. We're still not quite in the flames yet, or in the gas yet. But gradually, the entire planet just gets completely covered in lava. And here we are, just eviscerating this poor little world. And it's just gonna keep getting hotter. Because those are 2 exploding stars right there. Even when you're like 50 AU away from a star, you are no match for a supernova. The whole thing is just glowing on its own power now. It is inevitable. And now is when the mass lot starts to get out of hand. I think, anyway. Yeah, the mass loss is just going way up. The temperature just does not stop increasing. Nor does the mass loss rate. Everything is in constant acceleration. Now, because this is a relatively small planet, well, dwarf planet, it's not going to last as long as some of the other things. Like, somehow, Jupiter and Saturn are somehow still there. Hold on, let's take a look at Saturn real quick. What's Saturn's temperature? 11,472. Like, Saturn right now is a blue sun. And it's somehow still there. Yeah, exactly. We have iron as a gas, silicate as a gas, water as a plasma, hydrogen as a gas. What's the mass loss right here? Oh, that's the wrong graph of that. $221 Earths per year. Okay, yeah, so Saturn's about to go, but like it hasn't gone yet, just because it has so much more mass to go around. And you'll notice that there's like those little pieces of debris. Remember how I mentioned that like the little tiny pieces aren't interactive? Well, there you go. A supernova can't kill them. So we're actually starting to get pretty close to the supernova. You'll notice that the radius is starting to go down. It's really amazingly beautiful, isn't it? And somehow my computer's rendering it. Oh, we just shrunk down to 193 kilometers. Know why? Because all of our silicate just immediately disappeared. All we have now is iron. That's it. Disable what? The temperature graphs or something else? And we're about to die. Well, amazingly, the iron is a little bit more resistant to being inside a supernova. But yeah, you can see that it's crunching in on itself now. It's no longer a perfect sphere. Well, it still looks like a perfect sphere, but somehow, it's supposed to not be a perfect sphere though. Now it's crunching in on itself, and that right there is all she wrote. Oh, here's Pluto. Pluto's still alive. Even though it's actually inside the explosion now. We can actually click on the supernova itself now. Oh, the small... Oh! Oh, those. Oh, hey, a supernova has its own little... Maximum cloud radius, cloud mass, age. I can delete the supernova. Alright, anyway, now I just want you to see how far this thing can actually extend. Like, far more than it actually is supposed to as a real supernova. Because it gets ridiculous. See, it's still expanding. I've sped up time by a whole lot now. This cloud, this one cloud, like it's not even the full supernova. This one cloud has a radius of over 1,200 AUs. And we're still going. Pretty much, yeah. That is basically what it is. And Tona, you're some kind of naive to even think for half a second that Pluto makes it out of here. We had a happy ending with the moons, 137 and 90, but not here. It just keeps on expanding. Like, look at how big this thing gets. 9,000 AUs, 10,000 AUs. Okay, fine, maybe. But then it wouldn't have had a sun to go around, huh? Didn't think about that, huh? Then it would have been cold, then it would have been cold, like, down to absolute zero for all eternity. But then again, I could have just made another sun. Yeah, we are still going. And I really do feel like my computer processor has somehow handled the game better as the stream has gone along. Even though most of it was relatively boring. But yeah, like, this is Universe Sandbox. I hope you can see why I enjoy it so much. Anyway, we're still expanding. We're now into the light years. Like, a real supernova remnant should maybe take up... Let's see, how much space should a supernova remnant take up? Well, like, as far as, like, actually being this bright and beautiful and visible, it should take up, like, maybe... I don't know. 10 light years at the most. And the thing is, like, supernovae don't actually remain nearly as bright until like after about 3 years, the supernova is like no longer super luminous. And yet here we are in the year 2056, and the properties are still the exact same. Anyway, there's the Kuiper Belt. It's invincible. The Kuiper Belt is eternal. Unlike stars. Keep going. We're going at 9 years per second. And it just keeps blowing up even further. Like, this is way past the part where it ever would keep expanding in real life. Look at how many supernovas I can actually click on. Every single one of those circles is a different entity that just keeps on expanding out of this massive unit. Basically, yeah. Although you notice that the background stars haven't actually changed, despite the fact that we're now into 80 light years. The background is static, unfortunately, so we're just going to keep on seeing the galaxy totally fine. There's one more thing that I want to do before we go, though. All right, we're gonna boot up the regular solar system again. Oh no! All right, so we're gonna move the regular solar system. We're gonna shoot a black hole into the solar system and just see what happens.
Oh no.
Yeah, that pretty much sums up the entire game, doesn't it? All right. Let's have it be a 100 solar mass black hole. And we're gonna throw it at 375 kilometers per second. Throw it right near Jupiter. Right near where Jupiter is right now. Oops. I have the launch thing off. Oh, hello? Let me fire this thing. There we go. Okay. So we're gonna hold on the sun here as this black hole. Okay, we need to speed it up a little bit again. So, like, as this black hole comes into the system here, what the heck happens to the solar system? You know, besides the Kuiper Belt being completely unharmed again. It's worth noting, by the way, that the planets don't actually have any moons unless I tell them to, but I don't want to torture my computer anymore, and besides, I really should think about going to bed soon. Alright, speed it up. Let's try to speed it up a little bit more. Oh, cool, it worked. Okay, so will any of these planets still have the same kind of orbits? Wait, hold on. If I turn orbits on, that includes everything. Yeah, that's too much of a mess. So let's just like follow your favorite planet and see what happens. Oh wait, did 1995 TL8 actually get knocked out of the solar system by doing that? Oh, they are interactive. They're actually being sucked in by the black hole, sort of. But it's moving a little bit too fast to have them permanently sucked in. I don't remember it. Oh crap, it's just gonna blow up the sun. That's not what I was trying to do, though. Whoa! Oh no, we're good. The black hole's passed. But look what it did to the asteroid belt. The asteroid belt's going crazy. Wait, what happened to Uranus? I'm sorry, Subsonic. Alright, now I gotta check the orbital parameters for all the planets. Alright, how's Pluto doing? Oh no! Orbital parent is now the black hole. With an undefined orbital period. Oh no, what have I done? Oh, it's because the black hole, because the black hole is 100 times the mass of the sun, the black hole being anywhere near the solar system, by default, makes it the parent for any of these objects. So maybe I should wait a little bit longer for the black hole to go away. Or I can just, delete it. How far beyond the solar system is it? Oh, it's taking Jupiter along for quite a ride here. Goodbye, Jupiter. Wait, what does Jupiter look like now? Yeah, it didn't blow up the sun. Okay, so we're orbiting at 52.6 light years. Alright, I'm gonna delete this thing. Delete. Okay. So now everything should technically orbit the sun again. Because there's no black hole. By the way, nice Pluto model. Oh, this is the hemisphere that New Horizons didn't fly by, so... Oh shoot, that came fast. There we go. See? Pluto! Rotating the wrong way. It's rotating the wrong way because that black hole just came around and hacked everything. Alright, so what does its orbit around the sun look like? Okay, so it's back to the sun. That's good. Alright. Undefined! That's not what you want to see. Eccentricity 170. Remember, in order to knock it out of the solar system, all you have to do is make the eccentricity 1 or greater. But Pluto is now at an eccentricity of 170. What about Eris? That's even further away from the sun, so it probably didn't get... Oh my god, it was worse! It's actually worse. How did Eris get it worse? It was eccentricity of 653. Alright, how about Neptune? Not quite as awful, but like everything has just been completely stripped out of the solar system. For what it looks like. Alright, yeah, Uranus did not survive this. Sedna, did you make it out of there? Did you make it out of here at all? No! Like, for some reason, these super distant objects got hecked up even worse than the other ones, right? By that logic, maybe some of these other objects are okay. Well, that's better. It's Eris. Oh, wow, Sirius is almost still in the solar system. I think the problem is that the sun got taken along for a ride too. So like the sun is no longer a stationary unit. Like if the sun actually starts moving, then the rest of the planets are gonna have a hard time all keeping up at the same time. Also, this is a good series model. Just want to show it to you with Okato the Salt Crater. So yeah, basically I destroyed the entire solar system. Saturn, how about you? How are you doing? 30.8 eccentricity. Alright, this is another distant dwarf planet. Yeah, like they got it way worse. Yeah, I think it actually is more to do with the fact that the sun got taken along for the ride, because like, those dwarf planets that are so far away from the sun, they weren't really moving that fast to begin with, and they were really far away, so if the sun starts moving constantly away from them, then that makes it so impossible for them to actually keep up. So, they're just gone. Well, they're not gone, but, like, the sun and everything else just leaves them behind. Leaves them for dead, if you will. Okay, so yeah. Jupiter took the biggest ride along with them. Jupiter's now at a 675 eccentricity. They got kind of lazy with the gas planets. And oh wow. The entire planet is just black now. But you can see the model there. It's a decent model, I guess. Let's check out the surface temperature on Jupiter. Oh, actually, that's pretty normal. Even though the distance to the close, like Jupiter got hit so hard by that black hole that now it's 75 AUs away from the sun. How about, you think Earth is still orbiting the sun? Okay, this looks kind of normal, except like the maximum temperature on the Earth is barely above freezing. Oh, and Earth is now 8.83 AUs away from the sun. Yeah, every single continent is frozen solid. Also, I just realized that, like, right-clicking and dragging the model will change, like, the day and night. Left-clicking doesn't. So, like, if you wanted to see the Earth at a specific phase, that's how you can do it. Yeah, every single continent is frozen solid. Undefined! Okay, Earth did not make it. Earth is dead forever. I want to see this up close, though. Well, it's nice that the night lights still work. Hi, Sao Paulo. Hi, Rio de Janeiro. Hi, Santiago. Hi, Caracas. San Juan, Puerto Rico, looking good. Kingston, Jamaica. Mexico DF. Miami. But yep, not really a planet you can live on anymore. All right, how about Venus? You know, I destroyed Venus earlier. Wait, I haven't checked out Mars yet. How about Mars? Mars made it! Mars is still bound to the sun. Not by much, but Mars is still elliptical. It's still elliptical. It's really, really eccentric, but it is actually still elliptical. Notice that the range is from 15. Wait, no. Oh god, that's 1,525,000 to twice the distance from the Earth to the Sun. So like from 1.53 million to 298 million. So that's really terrible, and I don't think that's quite accurate, but I can always check. Does that actually look correct? Mars. That looks kind of correct! So, like, Mars is in the middle of just burning itself to a crisp, and then it'll spend a long time just way out here. Oh, Eunomia! The very first object that I messed with, Eunomia is fine! Eunomia is totally fine! Look at that! 0.174. Alright, so Venus is interesting because, like, wait, what? Is it me or are there trees on Eunomia now? What the hell? Did I just make this a habitable world? What? I turned Eunomia into a habitable world. Are you kidding me? At least it looks like I did. Yeah, check the life possibility. Oh, there's still no water on it, though, so... 19.5% Earth similarity. Okay. 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 This planet model is all fake news. It's actually not. But man, it actually looks like an Earth. Wait, what's the surface look like? Yeah. It's a little warmer than it normally is. Oh, I could totally give it water. Let's do that. Slow down time real quick. Yeah, we're still going too fast. I know we're good. No, we're not good. Oh, whoops. There we go. You know what? We don't want to spread it too much. You know me has a very pretty name for a world. Looking good, but it's quickly freezing over. It's still a little bit too far from the sun. But let's see how much good I did for the composition. Oh, not really all that much. Oh well, it looks nice. It's an upgrade. Alright, next. Let's check out Venus. I think Venus is still alive. Actually, yeah, we can just... Like, all we really need to do is just keep the, orbits tool enabled and just see how many worlds are actually still bound to the sun. Iris is doing alright. Juno, you know, that thing that we atomized in the last... not too distantly. Juno is fine. Oh, wiki. Wow, that actually kind of makes sense because, like, Eunomia is now green. And looks like it could legitimately be a good place to live. Alright, so what about this planet? Or, you know. Okay. Still not very good. It's still got an eccentricity of 0.501, but, like, it is bound to the sun. That's all we're really looking for. Alright, Venus, how about you? Venus is kind of weird because, like, it almost looks like a circle. Oh, I know. It looked like a circle before from some angle, but now it's a proper ellipse. And it's a very eccentric ellipse. How about Mercury? Alright, Mercury's a little bit more eccentric than it normally is. Mercury already has a pretty eccentric orbit in real life, but this one's a bit more eccentric. And then Vesta. I want to see if Vesta burns up when it gets close to the sun, because it's like Mars, where it just gets insanely close to the sun at one point and then just tapers off eventually. Well, actually, Mars is more interesting, so I want to see if Mars burns up when it gets close to the sun. Alright, I'm going to turn the orbits off. This will be the last thing that we look at. Oh, cool, my Roche lobe radius is going down. Because, like, if you're a planet and you're really close to the sun, then... Oh, we could try that. Well, if you're a planet that orbits really close to the sun, you're not getting any moons because it's just so much harder for anything to actually stay in orbit around the planet when it's getting that close to the star, which has a much larger gravitational attraction. Alright, hold on. Surface. Oh, now that we've technically got... Wait, I'm curious how... That's pretty good! Earth similarity. I think we improved Mars slightly. Except, no, we didn't, because if you have an eccentricity of 0.901, there is no way, no how you're ever getting life. Because Like, sometimes you're just completely burnt to a crisp, and other times you're freezing to death. So it's just impossible for life to actually sustain itself. Oh, there's the distance to the sun. So we're down to 37 million and change. $32 and a half. Okay, so it's not really changing that dramatically. I don't know why not. Just because this game likes to disappoint me. Not that it hasn't been totally not that it's been totally disappointing. Obviously, we've had our moments. Which is all. Which, you know, as a streamer and a friend, that's all we can really ask. Is that we have our moments where we're all happy. Probably right about here is where we have our best Earth similarity, because this is about the right average temperature, like average equilibrium temperature to the Earth. It's just that the Earth has a better atmosphere and a better greenhouse effect, so that its actual average temperature is not negative 24 degrees. But if it didn't have an atmosphere, then it would be negative 24 degrees. Obviously, there's kind of a dichotomy building here, as the night side of Mars is is obviously way colder than the day side. Yeah, I think I should stop after this. And just see what happens when Mars gets really, really close. Well, nothing's burning up yet. You can hear the roar of the sun's surface now. If you have headphones on, at least. Oh, never mind. We're done. That was as close as we got. Hi, Mars. That was as close as we got, but we're getting a little bit hotter because, like... Oh, red glow. Kind of. It's mostly just them. Oh, that's... Oh, that's interesting. Like, the atmosphere is glowing super hot down here where it's pointing toward the sun, but there's like no atmosphere at all on the other side. So that's kind of interesting. Alright, so Mars, I guess, can survive this.